video is going to cover crosstabs and some other important points. So let's put this in context. Remember that if you want to study how two categoricals or variables are related, then you're going to use a crosstab. So we're in this box right now. So what is a crosstab? We're going to use the defaulting customer case as one example. So a crosstab is really just a frequency distribution of all combinations of two variables. Right? So that's what I say here. Let's keep this really simple. And I've got two variables. I've got whether the customer defaults or not. I've also got the customer's gender. So this is what a typical crosstab looks like. They look just the same way from SPSS or SAS or Minitab. This one happens to be from R. So let's start out with the margins. Okay, so the total sample size is given down here. 24,975 is the total sample size. Now, on these margins, you get what's called a marginal distribution. It's really just a frequency distribution of the individual variables. So this 24,975 can be broken out into males and females. So there's 12,554 males, 12,434 females. These two add up to the total. Likewise, there's 2,923 defaulters, 22,000 and some non-defaulters, and these two add up to this. So that gives the marginal distributions. Again, there's nothing different between that and the frequency distributions from Chapter 3. Now the numbers in the middle give us all possible combinations. So let's just interpret this number. 1,296 is the number of females who defaulted. 11,138 is the number of females who did not default. The sum of these two variables will give us the total number of females, which is 12,434. Likewise, we can do the same for males who defaulted. Add that to females who defaulted, you get the total number of defaulters. So that's all a frequency distribution, all a crosstab is. Now, sometimes we want to estimate joint probabilities. So what is a joint probability? We'll talk a lot about that when we get to Chapter 6. Chapter 6 just talks about if we pick someone at random from this population, what's the chance they're in each of these cells? So if I were to divide these four numbers by the total, okay, I'd get these joint probabilities. So, and that's exactly what I have down here. So let's interpret this number. We can say that 5.189% or 5.2% of the entire population is female and defaulted. So 5.2% of the population is female and they defaulted. Let's do this one. 43.7% is male and did not default. Now the sum of these four numbers should equal 1, and sure enough, it does. Okay, so I challenge you to add those up on your own, and you should see that they add up to 1. Now, sometimes we don't care about these grand percents. We want to instead restrict our universe in different ways. So for example, maybe I want to know what is the probability that a customer defaults based on their gender. Okay, so in essence, I'm saying if I give you some extra information that a person is male, what's the chance that this person defaults? So the universe of males consists of 12,554 of them. So if we divide, for example, 1,627 by that, we find that about 13% of males default, as opposed to females. So about 10% of females default. Where did this 10% come from? Well, it's 1,296 divided by 12,434. So we can say that a higher percentage of females are retained than males. Males are more likely to default, is the story here. So if you're male, there's a 13% chance that you go away. If you're female, there's about a 10% chance. So a bit of a difference. So those are row percents, because what we're doing is we're restricting our universe to individual rows, as opposed to column percents, where we condition on the columns. All right, so let's just interpret this number. This number says 44% of the people in this column, so 44% of defaulters are female. And notice that 56% of defaulters are male. So it's really important to keep all these straight. The joint probabilities refer to everyone. So 5.2% of everybody is female and defaulted. This number conditions on the rows, so 10% of females defaulted. This number conditions on columns, so 44% of defaulters are female. Keep those straight. It's really easy to get confused. One other thing, as a general rule, you're going to be conditioning on the independent variable. So in this case, gender is going to be the independent variable, defaulting will be the dependent variables. I may have, so gender is going to be the cause of defaulting. It'd be hard to make a case that whether or not you defaulted causes your gender. All right, so gender is clearly the causal factor in this instance. Here are a few more crosstab examples. This is an example that we're going to be using again in this lecture. I call it the art museum income example. So it illustrates a very typical problem in marketing, which is media buying. So we often do media buying based on demographics. So perhaps I have 3 media vehicles, and one is targeted at low income, another one by medium income, third one at high income. And let's say I have an ad for an art museum. Where should I be placing this ad? Well, I want to place the ad in a vehicle that's likely to reach people who are interested in art museums. So we have to think through the independent and the dependent variable here. Income is going to be the independent variable. Art museums will be the dependent variable. We're hypothesizing that whether or not you attend art museums is affected by your income status, since that's the thing that's under our control. We get to pick the low, the medium, or the high income vehicle. All right, so then we care about the column percent. This happens to be Sas Output. So you get the same 4 numbers that we had up above. Here are your counts, joint probabilities, row percents, column percents. Now in this case, since we're interested in how income affects art museum visits, we're going to use the column percents. We want to condition on the independent variable. So let's just quickly interpret this. This says 39% of those with high income. So if we put our ad in the high income vehicle, 39% of those viewers or readers, whatever this is, go to art museums. Whereas if we stick it in the low income vehicle, you're only going to reach about 30%. 30% of low income readers are interested in art museums. 35%-ish of medium readers are interested in art museums. So the clear story is the higher your income, the more interest you have in art museums. It wouldn't hurt us to go through a few more of these percentages. What is the interpretation of 51%? Maybe you should just pause the video and write down the answer. The answer is 51% of people who go to art museums have high income? Let's interpret 18%. So pause the video, write down the interpretation, then I'll give you the answer. All right, the interpretation is 18% of everybody has high income and goes to art museums. So you'll notice that these, if you add up all these numbers, 8.3, 26.77, 28.6, 18.4, those will add up to 100%. Finally, what does this mean? 553, pause the video and I'll give you the answer. Okay, the answer is 553 people have high income and went to an art museum. What's the sample size? 3,000. All right, good. Another your turn. How does payment type affect default status? Well, looks like people who pay with book or statement have higher default rates than those who pay with either of the EFT methods. Another problem that we're going to look at for crosstabs. So how does the area, so in the CPK survey that we've talked about, there were two questions. Which customer segment are you in? So are you a new user of CPK? Are you kind of a light user of CPK? Are you one of their best customers and therefore you're a heavy user? And then we asked, what one area would you like to see improved? And people checked off one of these 5 boxes. So then we could ask ourselves a variety of questions with this. So here's a your turn. You can do these. So why don't you pause the video and try these on your own. All right, so what's the sample size? Sample size is 9668. How many people checked new items? Well, the number of people who checked new items is 3128. Question 3, how many heavy users checked new items? The answer is 1581. What percentage of people, so that means of everybody, are heavy users? The percentage of everybody who's a heavy user is 43%. Given you're a heavy user, so what that means is restrict your universe to this row, what is the chance that you checked new items? Well, the answer is 37.75%. So if you are a heavy user, there's a 38% chance you check new items. Question 7. If you check new items, what is the chance you're a heavy user? So if you check new items means you're in this column, use the column percent. So the answer is 51%. Okay, what do best customers want is question 8. What do new customers want? So if you're a best customer, that means condition on being a heavy customer, use row percents. The modal category is new items. So heavy users want new items. The second most important thing is value. Whereas if you're a new customer, the modal category is value. Second most common is new items. Actually, the third most common is new items. Second most is decor. So the point here is that if you're targeting your campaign at best customers, you want to pay attention to new items. If you have more of an acquisition campaign where you're trying to attract new customers, well, you want to focus on perceived value.